140H. This one looks awful familiar. I think I had found a bad cable on this one, didn't I? Or is this a different one? Yeah, no, this is the one I found because somebody replaced the cable. They're saying it's not connecting to radio, and yes, somebody put in a brand new cable, and it's blowing fuses still. Maybe there was more than one cable, I don't know. Or maybe they damaged something else. I don't see anything. They are saying possibly slope sensor is bad too. Just do a quick little inspection here. I'm not seeing anything out there. Let's see what the main fall sensor looks like. Yeah, see, that's a brand new cable they put on there. That's the one I found. Should be like the very first video that I've put up. If you go way back. Well, let's check it out. Yep, I would say that's a blown fuse. You know what I'm almost betting? I'm almost betting that that cable, because it shorted out, it was a pretty good short. Probably damaged something inside. But whoever installed that cable should have tested the system and got it up and running. So I need to call and find out who did that, who changed that cable out, and if they actually got the system up and running. Because they would have noticed if it was blowing fuses. Yup. I don't see any damage. Alright, so the word on the street is another tech came out yesterday, replaced that cable, and he did get the system up and running, and it kept blowing fuses until he disconnected the slope sensor. Once he disconnected the slope sensor, it stopped blowing fuses. So, it's either a cable or it's the actual slope sensor. And look at how old that is. That's an oldie right there. I mean, it's lost its color. But we'll test this cable. I don't see any damage anywhere, so that's interesting. But it's easy enough. We can test this cable real quick and then test that sensor. I did bring a new sensor, so. Alright, so all I did was do continuity between the two connectors through the wire. They all make continuity. They all have good continuity. And now we'll just do an ohms check on it. Check for resistance. They should all be about the same, really close, because it's the same length of wire. When you're checking for continuity, you want to check to see if any of them are shorted out against each other. So you basically, like this, you take D and you go around and you check all the rest of them. You should only have one connection, but if it's connecting to others, then you know there's an issue. I still have one left that doesn't go to anything, so, but these are all full, so that might just be the blank one. We'll just check the ohms, resistance. Alright, so simple ohms test basically tells me that E coming out of here, going into, and I can't read that, it's too dang small. Nope, actually E is over here, that one, that pin right there, going into that lower plug right there. It has a value of 17 to 45 ohms. Where all the rest were 1.8, 4.2, 9.0, which that's still a little high on A, 3.4, 0.8, which is really low, 5.0. But that one right there sticks out as being bad. Something's wrong with that wire. There's a lot more resistance to it. So something going on the inside of this cable, so we're gonna have to throw a new one on it. I'm not gonna test a new sensor with a cable like this. This is why you do that. You do not put a brand new sensor on a bad cable. Why? That's why. They're very expensive. So test the cable first, make sure the cable is good. It should be about the same resistance on everything. I mean, all it is the same wire, the same length of wire on the same connection on both sides. If it has high resistance, that means it either got crushed. If it has low resistance, that means it's maybe broken inside. Maybe one strand of that wire is actually attached compared to the 10 or 12 strands that are in that wire. So yeah, high resistance is never good. That means there's something funky going on there. So let's take that cable, we're going to isolate that cable, stick a new one on, and test the sensor. I just took the end off of it and cleaned it up a little bit. You can see this one here, the orange is just barely hanging on. If I check, that's probably the one. Yep. That's the one. That's the one that has the high resistance, or I mean the low resistance. The one that had the high resistance is the one right next to it. Let's see here. Because you see how it's folded over? It's the blue one. It's actually touching the blue. So it's creating more resistance. You see that? It's actually bent over and touching it. Yep. Interesting. Just needs to be resoldered on. Just make a new cable for them. And after a closer look, this is the way the wire pattern is. You can see the two center pins have no wires on them at all, right? Look at what my continuity check said. Continuity said it was going to B, which B is yellow up to here. So that yellow was touching. What was the resistance on that one? 0. Oh wait, yep, 0. 0 on that. But I was getting continuity to B, and it shouldn't go to B. So that's interesting. Yeah, it was all messed up in here. All messed up. Look at that wire. And then there was another one over here that's bad too. And we'll desolder those, cut it, and reuse the wires and just resolder to the connector. Cleaner connection. Unfortunately, this solder does not want to go onto this corroded wire. The wire is too badly corroded. We're gonna have to get a new one. It was worth a try anyway. Just will not go onto that corroded. And it's corroded all the way through that wire. Interesting. Well, we'll just have to get him a new cable. Test it then. I would make a new cable, but this one, this other end, this one's factory. I cannot take that out. I cannot take that apart and resolder it back together. Because I got the cable, got new cable, but I don't have this other end. And that's definitely factory. This is the changeable end, and that cable is just, that wire is just really bad in there. You see it, it's all rusted and corroded and does not want to take that solder. Look at that. Nasty. Do you see the corrosion? And it goes all the way through. That's just bad wire. Bad wire. Ugh. Hate not being able to fix something on the spot, but I even cut back even more. I can't cut back too much. That's just going all the way through. Just bad, old bad wire. And it's so corroded it won't take the solder. So, all right. Well, we'll go get a new cable and we'll do it that way. Well, that explains all the corrosion that I found. Well, all the ohms resistance readings that I found, all the differences. Some had some serious corrosion while others were actually shorting out. Like this one was definitely shorted out. And the higher the number, it probably had a whole lot of corrosion. So yeah, that's why it's a good idea to check the cable before you go ahead and put, you know, a brand new sensor on. Because you know, that all that resistance right there, that could definitely damage all the internal components of that sensor. And just makes sense, right? All right, so going to get a new cable. We'll come back. We'll test out this. We'll test out their old sensor, and I bet you it's still working. Bet you it's working fine. Just needs a cable. So, on my way to do that. And yep, see you when I get back here. Well, alright, we got the new cable. There it is. So I am going to leave the sensor in place, take off my protective tape, connect it, and give it a try. Hopefully it doesn't blow any fuses. Alright, new fuses in. Let's turn the power on. I think they got their dead man switch off. Switch is on the back. Yeah, they got their dead man switch off, wherever that is. Let's go find that. You would expect it to be up here with the batteries. Nope, no such luck. Where is it on this machine? Sometimes they're over here. Yeah, of course. And you need a key. I don't think I have that. Did they leave it in here? No. Alright, so you come out, you do a service call, and they turn the power off. And they take the key with them. Nice. Nice. Well, luckily I found somebody. They had a key. It's interesting because I have the same key, but mine has little nubs on it. They said they have to shave it down for this one for some reason. So yeah, we can at least check the power on it. Need that, need power. So glad I'm not a shop tech. They spend what, probably about 60% of the time pushing a broom, 40% of the time working. From what I observed. Yeah, so alright, let's get this thing started up. I might have to shave mine down if that's the trick. So yeah, look at that, it goes in. Nice. Alright, let's check it out. Power. That's the sound. Alright. Alright, come on, don't pop. Oh, it blew the fuse. Blew the fuse. Now, if you remember, if you go back to the very first video that I posted on this YouTube site, you'll see that all I did was disconnect these cables. And if you disconnect this one, which we'll give it a try, it might have more going on than just that broken, cut up, messed up cable. Put you down for a second. Alright, so we disconnected that cable. And look at, power's up. That is the brand new cable, the one that I identified as being bad. Alright, so follow that back. It goes into the main fall sensor. So what over here is causing another issue? I don't want to believe that it's the sensor. There's got to be more to this. I've just never seen a sensor pop a fuse like that. And as he was going up in here to replace this cable, I'm sure he would have checked out all these other wires. At least I hope so. Yeah, I know who did it, so I'm sure he did. Sure he did. Could be a dead main fall, but let's go ahead and we'll swap that sensor out just to see. We don't even have to take that off, unscrew it or anything. We just take this cable off, connect it up to there we go. I mean, that was a bad cable that was on there, no doubt about it. Let's turn the power off here. Don't need any power surges. Kill the power to the vehicle and throw a sensor on there. Now, bad cables can cause bad devices, but man, that's got to be pretty bad. Something is not right. And you know, the other thing, we got this really long cable here, and if this is in the same condition as the other one that I just got done replacing, this one here, then it's safe to say that the wires are corroded inside, causing all kinds of resistance, maybe even shorting out. But now I'm leaning towards this main fall, but let's check it out. Let's throw a sensor on there and check it out. Alright, new sensor in place. I mean, that is an ancient sensor. Look at that thing. Ancient. Let's go power up. Give it a shot. We'll stick this back in there. Well, good news. it's holding. I've just never seen a sensor cause a system to blow fuses. Yeah, give you bad readings or no readings at all, but to blow a fuse is putting a significant amount of resistance on the system in order to blow that fuse right there. So interesting, just completely interesting. Let's see what we get here. So we'll just set their slope, we'll correct it for them, we'll check blade rotation, we'll check main fall, and might as well. I mean, it's working. It is working. Interesting that it would be a slope sensor. That cable probably took out the sensor, and the combination between the cable and the sensor blowing this fuse. I've just never seen that. First time for everything, I guess. Alright, let's get this thing squared away. This is what kind of day I'm having today. Stripped out. How are you going to get that out of there? What tool are you going to use to get that out of there? That's the question. A grinder. Knock the ear off of it, shoot a little juice in there. We'll try it with a pair of nice needle nose. See if we can't get a good grip on that now. Just might need to grind that down a little bit more so I can get flatter. Ta-da! It's all stripped out. I tried hammering the Allen into it, but it wouldn't go. And we even saved the screw, but it's all boogered up. I'll have to put new ones in there. Man, that is an oldie. Yeah, it could function without that ear on there. It doesn't need it. Well, I did take some of the serial number with it. That's alright. I took a photo of it beforehand. Alright, just clean this up. Clean out those bolt holes. Find some new bolts. Put the new one on. And get the slope set. There we go, all cleaned up. I like to add a little paint to it just to cover up some of that rust, clean it up. Might as well just put a little paint on it while you're there. Make it look the way it should look. That's it. And we'll put it down. As you grader operators know, that they articulate, right? So make sure you can drop the pin in so the articulation is centered. And then you just go from this spot. You can go use the tip of the blade, or any portion of that blade would be fine as long as you match the same thing on the other side. You're just measuring both sides, getting that table square to the machine for rotation. All right, blade, carriage, everything is lined up. And blade rotation is 0, so that's good. Blade rotation is good, don't have to mess with that. Let's just do the slope now. And that's as simple as just taking a level. Oops. Just take a level to the blade itself on the cutting edge and get it at 0. I gotta go up higher on this side. Yeah, I want to fix that. Good grief. That can't be right. Blade is at 0. Let's see what it's saying. It's got a new sensor on it, so it's going to be different. Well, that's not too bad. 0.2. That's not too bad at all. Interesting. Well, 0.3. Needs to be 0.0. Oh, this old software, it's not letting me, if you go to the sensor values, it's not letting me change anything here at all. So we're gonna have to do this the long way and do it through calibrate sensors. Rotate blade to chisel marks on frame so that the blade is square to the machine. Press next. First blade position. This is for the main fall. I don't need to do the main fall. Why aren't you letting me? I can change these two and that's it. Oh, it's gotta be this old software. It's gotta be in here. Alright, so we'll just go through this. Alright, yeah, you had to go through the whole entire calibration process. You can't just touch on it and change it, which is weird. But we're at zero, machine is good. Alright, okay, and we're green, so it's good. Fire's up, it's ready to go to work. Nice.